Welcome to Update on Closed Loop Studies with Dr. Buckingham. I'm so excited to hear this presentation and learn from Dr. Buckingham. I've known him for quite a long time, and I'm excited to learn a lot. If you have any questions throughout the presentation, then feel free to send me a chat, and you can either ask me the question or let me know that you have a question so we can get you unmuted and you can ask Dr. Buckingham. And then I'm sure we'll have time for questions and answers at the end. So with that, I'm going to kick it over to Dr. Buckingham.
Okay, so is my screen being shared here?
Yes.
Okay, you can see it. Good. Okay. It's off to one side, so I'm going to be looking down the beach, and I'm not trying to avoid direct contact with you, but I always want to make sure there isn't one of those strange sort of outlier waves coming in that I'll be washed away before the presentation's over. So Rosa I've known Rosa for, it seems like decades, and she has, when I present closed loop studies, she has presented in a lot of the work that went on to bringing these things to life and into the marketplace, and has been a volunteer for years and years. And I saw her dad there, and really appreciate all the volunteers that have helped over the years to move this forward. And now we sort of accept it, but it wasn't without a lot of work and people volunteering to do it. So thank you. And I got to say, one of the things I really miss about the camp is being able in reality to sit down at a table and talk to people and meet people and exchange stories. And I hope you all do that virtually in some way. And please feel free to intervene so we can have conversations as we go through this. So I don't have my slide. There we go. I just got to say, this has been an amazing year. So much has happened with COVID. I think diabetes will never completely be the same again. We've really moved to telehealth visits, which is really great because you can talk to people and actually, for a doctor, it's like doing a home visit. You get to see, be in someone's home, see their family and the kids running around, and we review data. We do about everything you would do in a visit except a physical exam and getting an A1C or lab tests. And I really think this is really showing the value of continuous glucose monitoring. And I'm going to go over that in a little more detail, but I think it's actually better than an A1C for looking at short and long-term risk for diabetes. An A1C gives you no measure of hypoglycemia. It's also, I think, highlighted as we've been at the ADA meeting in a number of places, the health disparities that go on. And if you look at the people that get enrolled in closed loop studies and CGM studies, it's generally people who are from a higher socioeconomic class. And it's something, there's a bias in healthcare delivery, and they want to see that someone's doing enough blood tests, is giving enough meal boluses before they will enroll them if their A1C isn't too high. And these are the very people that do the best that I'm going to show in terms of showing an improvement when they enter a study. They really have a huge benefit from this technology. So we really would like to have technology available to everyone, irregardless of their insurance coverage. And I really still believe that health care in America should be a right and not a privilege, and that if you have diabetes, you should have equal access to the things we're going to be talking about, and someday maybe. So to just sort of put A1C in perspective, since no one gets it now because we aren't having virtual visits, this is the studies from the DCCT, the Diabetes Control Complications, and it looked as A1C went up, this is relative risk. So if your A1C was 9, you had about 100% higher risk, well, not 100, but it was a 50% higher risk of getting eye diseases or kidney disease. And when you went up to a 10, it was about an 80% risk. And so as your A1C went up, your risk of complications really went up. And There was a recent study out of Sweden where they actually do have a national health care, and they were actually able to follow all their children and adolescents from childhood into adulthood and look at their the incidence of eye and kidney disease as it developed. And what they found was, this is years of follow-up, 16 to 20 years, 14 to 15 years, and down here, 8 to 9 years. So these are people that actually have access to the more recent technology. And these are people that, you know, were before there were sensors, they were involved in their diabetes. But you look at the complications, and this is actually probability. So you go from 0 to 100%. So you get down here and you're beginning to see a couple percent, maybe a 3% risk of complications. And that's with an A1C of 8.6 with 16, 20 years of follow-up. And if you look here at an A1C of 7.5, it's almost nothing. And here's an A1C of 6.9, or about a 7, and here's a 6.5. So there isn't a huge difference in terms of your risk going from a 7 to or a 7.5 even to a 6.5. So I think that's really encouraging. What you do see here is risk going up at this end, and that's as you got lower A1Cs, you had a higher risk of seizures, loss of consciousness. So there is something on the extreme downside. That may change with closed loop because now you have automated insulin delivery. And so a lot of the, when you look at 16, 20 years of follow-up, they didn't have a sensor or closed loop automatically delivering the insulin to prevent a low glucose. So this is just the A1C. And here, I think it's a really important thing. Here's an A1C of 7. And if you look at this, you can have an A1C of a mean glucose of 125, 130, or you can be up to 180, 190. Now, this is the mean glucose done by a continuous glucose sensor. So it's what's a measurement every 5 minutes. It's in the sub-Q space. So that's the glucose that's bathing your tissue. It's bathing your kidney, your eyes, where the complications occur. And so it's probably more important to know what's bathing the tissue, what's affecting your kidneys, what's affecting the eyes, compared to what's in your red blood cell that circulates around in your blood. And so if I was to rely on something, I'd rely on the mean glucose by a CGM for my risk of long-term complications compared to just the A1C. The A1C, I just want to, I'm showing this gap here, is altered by anything that affects the red blood cell lifespan. It's done as an easy test that we can draw from a finger stick or from a blood sample, and it measures old and red blood cells. Now, if you have something that's turning your red blood cells over more frequently, say you have heavy menstrual cycles, you will have less old blood and more fresh blood, so you will have a lower A1C. If you have anything like hypothyroidism, a whole set of other conditions, race, blacks for the same mean glucose have higher A1Cs than Caucasians for the exact same mean glucose. A whole set of drugs, as you can see here. So there are a lot of things that affect the A1C which make it not accurate. And in a typical adult clinic, 14 to 25% of the A1C levels do not correlate well with the mean glucose. So when we look at time and range, which we get with the CGM, it correlates very well with the mean glucose. It does not correlate well with the mean A1C. So this is a much lower correlation. And if you increase your time in range by about 10%, it correlates with an A1C decrease of about 0.6%. So we really look and try and get people with an A1C with a time in range of 70%, which correlates to an A1C of about 7%. So that's the time in range goal. And when we look at these closed loop studies, a lot of them may not have A1C levels but they have time and range levels. So that's why I'm bringing out this correlation so you can think about it. Okay, I'm now going to go into closed loop systems, and I can't see hands, but I hope everyone attended Lisa Norlander's talk yesterday on Tandem Control IQ. I know there are a lot of breakout sessions and a lot of things that they use. So I'm going to be pretty brief with Control IQ, assuming the people that were really interested in this listened to Lisa's talk yesterday. I'm going to talk a little about the new Medtronic system that's going to be coming out, the advanced 780G system, and about the Omnipod, Omnipod 5 controlled by the Horizon algorithm and the studies that are going on with that. And that's going to be coming out probably first quarter next year, and a little bit about Beta Bionics and the iLet, and anything else you guys want to talk about. And so with that, does anyone want to ask any questions about A1C and time and range? Or did I beat that to death?
How well does it correlate with fructosamine?
Fructosamine has is measuring sort of the albumin, and it has a shorter lifespan in the blood. So you can get an average what your glucose is over a few weeks. With a glucosamine, it's not affected by red blood cell lifespan as much, and that's why it's used when people, you can't use an A1C in pregnancy because the red blood cell lifespan is so much shorter, so they use fructosamine in pregnancy. But the assay itself has a much higher coefficient error and variability on any given measurement for reproducibility. So I think time and range is a very good measure in all those conditions. It's directly measuring glucose, and isn't indirectly measuring albumin or some other protein in your body like hemoglobin.
Dr. Buckingham, there's another question here. It says, I'm curious about times when, without any of those conditions, A1C doesn't correlate with recorded blood sugars.
Yeah, I think there are genetic differences and there are individual differences. And what some people have done, Boris Kovachev at University of Virginia has developed a predictor of A1C, so you get your estimated glucose, your estimated A1C from your mean glucose. And if you take one value, and we've done this, we've tracked people over a year with continuous glucose monitoring for a year and A1Cs every 3 months. And there will be some people that will consistently run higher A1Cs than you would predict for their mean glucose, and other people that will consistently run lower. And it can track very well with an individual over years. So yeah, there's an individual difference in whether it's the red blood cell lifespan, exactly what's accounting for rate of glycosylation of the hemoglobin. There are a lot of different potential reasons. Most of it, I think, is red blood cell lifespan for individuals.
Okay. And then there's a few other questions. When Dexcom doesn't reflect lows that the meter shows.
Yeah, that's maybe a combination of, first of all, the first 18 hours of a sensor, probably they aren't quite as accurate, and they get a little more accurate as time goes on. If it's a Medtronic or a Dexcom or a lot of sensors, it's just that initial tissue trauma. There can be people lying on the sensor and these, nocturnal sensor compressions, pressure sensor attenuations they're called, or the sensor may be just reading off, and there's also lag time. So you may be getting low and the sensor is lagging behind. And that's why a lot of like on Dexcom, they have a predicted hypo, and it's predicting where you're going to be based upon your rate of fall and how you're going. And often by the time you do a finger stick, your finger stick will show you low and the sensor is heading down but hasn't gotten there yet because of the lag time. and the sensor could just be off. It could be miscalibrated. So, I mean, the sensors are doing good if they're plus or minus. We would love them all to be less than an error of 10%, but often you're closer to 15%. You know, a lot of them are within 15% range there.
Okay. Isn't 180 too high to be considered time in range?
Well, you can have different time and ranges that you can set up. We did a lot. You know, one of the things in setting up a time and range, if you set up the time and range should be 70 to 140, a lot of people with type 1 would look like they were failures because it's really hard to keep it less than 140. And we really felt it was realistic to have a goal of 70 to 180. If you're a type 2, maybe a target of 70 to 140 may be more realistic to try and get. And again, as it turns out, if you look at that risk of complications as it relates to A1C, which then relates to a time and range of 70. So an A1C of 7 correlates with a time and range of 70% in that 70 to 180. So we've worked out the correlations between them, and we've just sort of come upon that standard for type 1 and reporting CGM data. For a given individual, they could try to keep it tighter. I'm not sure that you're going to see a big difference in long-term complications looking at the data I just showed you by trying to keep everything less than 140, and you're probably putting, if you have type 1, yourself at a much higher risk for low blood sugars.
Okay. And then last question here, at what percent of lows below 70 affect the A1C and mean glucose?
Well, everything has some effect, and when you're low, you aren't attaching sugar to your hemoglobin as much. But the actual percent of time that you're low is a small percent of the actual time in range. Most of the time in range is affected by the time that you're high, because people don't spend a lot of time low. They don't like to be low a lot. So remember, the goal for time in range is less than 4% of the time less than 70. What does that translate to? How many minutes in a day is 4%? Well, 1%, there are 1,440 minutes in a day. So 1% is roughly 14 minutes. So if your 4% is close to an hour, less than 70. And people don't generally want to be more than that. And if you look at 54 as a target, and we want to be less than 1%, less than 54, that's still 15 minutes less than 54 a day. So, you know, having more time in hypo means you aren't glycosylating as much, but you really don't want to spend a lot of time hypo to lower your A1C. It's much better to top off the top end. Okay. Wow, we may get the closed loop here. But it's important to set our goals. Okay. So closed loop, you have a pump, you have a sensor, and you have an algorithm that decide how much insulin to give from it. This is the tandem that Lisa talked about yesterday. For any of you that didn't go to her talk, I'm going to try and use some slightly different slides and give my own little innuendos on it. But it uses the Dexcom G6 without CALs, which makes it nice that way. And it has this Control IQ technology, and you can upload. And this is just the concept that it's aiming for a target. It's a treat to range. And the range is 112 to 160 during the day. And if you're going to be predicted 30 minutes in the future to be above 160, it begins to increase the basal. And if you're predicted to be over 180, it will give a correction dose if you haven't had a correction dose in the previous hour. If you're predicted to be less than 112, it will begin to decrease the basal. And if you're predicted 30 minutes in the future to be less than 70, it will stop basal insulin delivery. We, in our closed loop systems, find that you can sort of give what's called a super bolus, where you can be more aggressive with the meal bolus, because on the back end, you can shut off basal insulin delivery. So you can give more up front to cover the food, and then on the back end, let the controller handle it. So typically, you take the total daily insulin dose and you divide it into 450, and that would give you your carb to insulin ratio. And when you're in closed loop, I generally use 400 for that number. And typically, breakfast requires more insulin. So we use like a 360 rule divided by the total daily dose. And in closed loop, I tend to use a 300 rule. And just as a ballpark figure for where to begin. And everything's trial and error in diabetes. You come up with a number, you see how it works for you, and you adjust it. So with Control IQ, the target glucose ranges are not customizable. That target is fixed. If you want to use the temp basal, you got to stop Control IQ. The insulin onboard time is not displayed, but the insulin onboard units are displayed. You can give an extended bolus for up to 2 hours. The insulin duration of action time is fixed at 5 hours. And again, the autocorrection boluses occur every hour. So I'm not going to go into great detail about this, but I just want to say the sleep lowers the target from 112 to 160 to 112 to 120. And you should reach that target within about 5 hours of activating it, if you've been high, even if you've been high. And you can set a sleep schedule for different days of the week. Now, every day is Groundhog Day and COVID-19, so it doesn't seem to make a lot of difference. The only thing I notice when I look at the kids, they're tending to go to bed or sometime around midnight or 1 o'clock, and breakfast is generally around noon. So it's really shifted things a bit, but you set that. You just set your sleep schedule, and it comes to that. The one thing in sleep, you don't get the auto corrections. You get the lower target, but you aren't able to get auto corrections. So it doesn't help when you're getting meal excursions and things like that. And that's the little Z showing up here. And you can also have an exercise. And the exercise takes the, and you should really start about an hour before exercise with that, so you have less insulin on board coming into it. It has the same upper target, but it changes the lower end from 112 to 140 as the range you want to be in. And instead of stopping at a prediction of 70, it stops at a prediction of 80. And the issue we found sometimes is that if someone takes carbs when they're exercising for getting low, it will trigger a, that rise in glucose will trigger additional insulin coming in. And you're still exercising, so now you had a low, you treated, and now it gives more insulin, and then you can get this sort of yo-yo. So we recommend sort of using less carbs when you treat during exercise, or actually exiting Control IQ and using a temp basal. Whatever works for you. And everyone's exercise is different. Every sport is different. And you just gotta learn what works for you. For a lot of people in the study, the exercise function worked well. I will say that. There are hard alarms, and I think the hypoglycemia predicted, it goes off based upon not only the predicted glucose, like Dexcom, but it also takes into account the insulin on board. So when this one goes off, you should treat it. And you can treat maybe not 15, but at least 8 or 10 or 12 grams of carbs, because it's predicting with the amount of insulin you have there, plus the rate of change, you're going to get low. The other one is the hyperglycemia, and that's for 200. And if it predicts you're going to be over 200, and even given its correction bolus, it's not going to be able to bring you down, it will set off this alarm. And it will go off every 5 minutes, which can be annoying. So what you do is, when this is going off, you go in and you give a correction dose. You just put in for your bolus, no carbs, but it'll give you a correction because it knows you need more insulin. Put in that correction dose, and that'll silence the alarm. This is some of the printouts we look at, and this is what we had in the study. And you can see here, this was a late meal bolus. You can see they began to eat here and they bolused here. And they did come down. Here you can see that they missed the meal bolus. And so this is an auto correction by the system kicking in here. And here's the next meal, and they were late with that also, but they entered the carbs here. And it gave auto correction boluses every hour to bring it down. This is a new printout with that's the commercial one, and you can see it shows sleep. You see your Z's, which is nice, so you know when you're sleeping. These are the auto correction boluses. You see this little drop and this little blue hatch line, and that's an auto correction. So in our study, in the pivotal study, what people liked about it, they liked they could sleep through the night. They thought they had better control with less ups and downs. It was less disruptive to their social life. They thought it decreased the burden of diabetes. They liked the auto correction. They liked the pump was small. They didn't like the heart alarms for the highs, but I told you how to sort of avoid them. Some thought the exercise wasn't robust enough for their exercise, and thought the cartridge change process was a little more tedious. What they mentioned was that the basal rate is critical, and that you should follow the pump instructions and dose and give the correction doses as it tells you to, and not to override the system. To bolus before eating, 10 minutes is best. And you can adjust the volume of alarms and use vibrate only and things like that. And don't give meal boluses late after an auto correction has already been given. Because then if you enter the full carbs late, you'll give the insulin for the full carbs. The system is already given a lot of insulin, and then you'll end up with a late low. Okay, this is what I thought was one of the most interesting things about the study. If you look, this is day baseline, and this is day one. And the time in range has jumped up to 70% on day one of starting the system. So it isn't something that we did, tweaking the system a lot, that got people up there. It began within a day, and they pretty much stayed that way. What you did see after the first week and you went on to the second or third or fourth week, the variability. There were some people that weren't doing as well, and you cut down the variability. So you got rid of the people that were having more trouble and got them in a tighter bunch. But the overall mean didn't change that much from what you got the first day. And that's the algorithm working, and it's predominantly working, which you would expect on your first day, overnight. So this is your time in range going up to close to 90% at night overnight in the early morning hours, getting that target of 112 to 120. And then during the day, it's getting more time in range throughout the day. But you see this effect immediately your first night. And the other thing that I just wanted to bring up is that you took people who started off with very good A1C, 6.5%. And Leah Elkesper at our group did this analysis. And what they saw was predominantly a change in the percent time they were hypoglycemic. That went down. They also got a little improvement in their time in range from decreasing the hyper. But it was a lot of improvement in the hypo. On the other hand, people that came in with an A1C of 8.5, and we had people with A1Cs of 9.5, 9.6, and they ended up the study with A1Cs of 7.5, 7.3, and you see a significant improvement in the time in from hyperglycemia. This is a hyperglycemia, and it's significantly cut down. Little change in the hypo because they're on high all the time. But if you look at what happens at night, for the people with very tight control, they do much better in reducing the lows. Big reduction in their nocturnal hypoglycemia, as well as some decrease in their hyperglycemia overnight. People can't be awake and make a decision every 5 minutes through the night. This system can do that for you. It's making a decision every 5 minutes. And again, at night, for those that were forgetting the bolus, and this group came into the study doing about 2 meal boluses a day. This group came into the study doing 6 meal boluses a day. So they were missing a lot of their meal boluses. And I will tell you at the end, they still missed a lot of meal boluses. Our talking to them every 2 weeks didn't change that behavior. I mean, it's a behavior. And they just forgot. So, but the system took over and really helped improve things. And so that was what was nice.
Dr. Buckingham, we have a question here. So before Control IQ, I could set a temp basal of, say, 50% during moderate to high exercise. But with Control IQ, the only way to do a temp basal is to change the basal rate. Will exercise mode help with this need?
Exercise mode, you just need to exit. If you want to go down to 50% and a fixed base, you need to exit the Control IQ and go into manual and put in a temp basal of 50%. And when you're done, go back. The other thing with the exercise mode, when you're in Control IQ, is there's no duration on it. So you got to remember to go back to the Control IQ. You got to remember to turn off exercise. Otherwise, you will stay in the exercise mode and your blood sugar target is 160 and you will not bring it down overnight. So you wake up in the morning at a 160 glucose instead of your 112 to 120. Any other questions on Control IQ? Okay. The new Medtronic 780G looks a lot like the 670G because it's the same sensor, the same meter. Only the guts have been changed, only the algorithm's been changed. But it allows a target of 100, gives automatic correction doses every 5 minutes. The commercial version, when it comes out, will have Bluetooth. So it will talk to your Apple and Android phones for remote monitoring. And they're aiming for a Medtronic sensor which currently requires 2 calories a day, to go down to 1 cal on the first day, which would be a significant improvement. That timeline on this is not given. Timeline on this is probably within the next 3 to 6 months. I mean, probably before the end of the year, they should get approval for this, I would hope. These are the differences. You have a target of 110. The correction bolus is not to 150, it's to 120. The minimum insulin timeout before exiting auto mode went from 2.5 hours to 3 to 6 hours. Maximum insulin timeout exit went from 4 hours to 7 hours. Maximum time in safe basal went from 90 to 4 hours. The no exits for running high. For 3 hours over 250 or 1 hour over 300, you don't exit. So it essentially eliminated almost all. We haven't seen auto mode exits for these reasons in the clinical trial. They're essentially gone. So that got rid of a lot of alarms. This is a study that was presented, but it was 157 people, 39 adolescents, 118 adults. And the important thing here is their A1C when they came in was around 7.5, 7.6. So these are pretty well controlled people. And this is the study. You have a 2-week run-in, and then you're set at either 100 or 120, and then if you're at 100, you cross over to the 120 set point. If you're at 120, you cross over to the 100 set point. You do each one for about 6 weeks. And these are the results. But instead of, it's hard to read all this, so I'm going to simplify it a little bit here. What was found out during the study, when they started out, everyone was told to set the active insulin time, the insulin on board time, to be greater than 4 hours, the 4 hours or greater. And as we were doing the study, people began to lower it and found that actually if they went down to a 2-hour active insulin time, they were getting close to 79% time in range at a set point of 100. And at a set point of 120, it was about 75% time in range. These are good numbers. And if you look at the percent time hypo with the short active insulin time, it stayed around 2.6 to, it was less than 3%. Whether you're at 100, it was about 2% if you were using a 120 set point. got very slight increase in hypo with the 100 set point, but still less than 3% a day. So that's sort of the same numbers. If you use a shorter active insulin time, you do better. Yeah.
Can you explain the AIT on the last slide?
Active insulin time. It's what you use for active insulin or insulin on board, whatever you think about. Often people will set it to 3 to 4, or sometimes adults 4 to 5 hours. In a lot of our pediatric patients, we set it at 3 hours, 3 to 4 hours. So,
can I ask a question? So I don't totally understand that. Why would you change it? I thought it was dictated by the insulin itself, not a self-imposed thing.
Well, actually, if you did it by the insulin itself, you'd have everyone at 5 or 6 hours. Because that's the actual insulin on time. It's used partly because when people want to give a correction dose, you want to make sure you aren't giving too much stacking. So if you've given a dose of insulin and you've waited 2-3 hours, say 3 hours, and it hasn't brought your blood sugar down, you want to give another correction dose. You don't want to wait 4 or 5 hours to give another correction dose. And so people will set it for 3 hours so they can give a fairly aggressive correction dose and not be subtracting from the correction dose for insulin on board. What's happened with the algorithm, that it has enough hypoprotection built into it that even if you lower the active insulin time, all these algorithms aim to prevent hypoglycemia. So it has enough breaks and safeguards that it allows the algorithm to be more aggressive in basal increases and these automatic correction boluses to give more. So it's less braked on the hyper side, but it still contains very good brakes for preventing hypo.
Thank you.
So it's engineering and algorithms. It's more than the reality of insulin action time. Does that make sense?
I think so. Probably 80% of it, and I'll digest the other 20% after this call.
Okay, but all these systems have different modules. So they have modules to prevent hyperglycemia, and they have modules to prevent hypoglycemia, and it's all and they're sort of working together. But the one that's often the ultimate controller is the risk of hypoglycemia. So if it sees things that are a high risk for hypoglycemia, that trumps. I mean to use that word. It overrides the other system. Okay.
That's good.
Okay. So, and this is just showing the automotive exits a week are much less. They're about 2 a week compared to about 6 a week on the 670G. And this is an Australian study taking 14 to 21-year-olds, not in great control. And you can see they do much better overnight and also do much better during the day in eliminating some of their peaks and things like that. So that's it. Okay, anything more on the Medtronic 780G? I'm going to tell you, we've been using it. We've been doing that study in 7 to 14-year-olds. And I've been really impressed with the control we get. It's one of the more aggressive systems out there. It does well without a lot of hypo. So this is the Omnipod. Ready to move on? Okay. So the Omnipod is sort of unique in that the sensor, the G6 sensor, is talking directly to the pod. And the pod has the algorithm in it. So as long as you have these two on your body, which you should have at all times, you're in closed loop. And you can go swimming. You can do a lot of sports. When you're taking a shower, it's working. We've had people who are swimmers who said it's been working when they're swimming. It shouldn't work underwater, because Bluetooth doesn't transmit underwater, but they're saying it's working. When they download, they can see it was giving. I had one girl on another closed loop system who swam across Lake Tahoe 2 weeks ago. That was a 8.5-hour swim. And I wish I had this system on her, because I could really tell that if it really does work with an 8.5-hour swim. Most people don't swim that long. So pretty impressive. This, I got to tell you, this system, we love this because this is waterproof. So you can put it up here on the babies, right in their diaper, no problem. It works well. And after 3 days, you throw this away. So as you know, we have COVID-19 going on. About 25% of the people admitted to the hospital have diabetes, mostly type 2. If they have in the hospital high glucose levels, 80% go into the ICU and go on a respirator and are very sick. If they keep their glucose values in really good control, and like you can get with a hybrid closed loop system, only 20–30% go on to intensive care and require an intubation. So we're working to get this on the COVID units. I think it has a lot, and it would be really fantastic in hospitals because you're not sharing equipment. You don't have to buy a $7,000 or $9,000 pump for someone to put them in closed loop. Also, we've tested and we can remotely bolus for this outside the patient's room, and we can remotely monitor them outside the patient's room. So there were no large N95 masks at Stanford a few weeks ago. And because every time you go into a room to do a meter test or deliver insulin, you're putting on the PPE and then you're taking it off before you go to another patient's room. So but if you can do everything outside the room, it makes a huge savings on PPE too. So I think this system may have a lot of utility. This is my thinking. We just got to get funding to do it. Who cares about money? Okay, this is the system, and it does have a Samsung handheld controller. On it is a Horizon app and also a Dexcom app. And the sensor is providing data to the Dexcom app and directly to the pod. On the app here, for the Horizon app, it's collecting the data from the pod, which you can also click on the Dexcom app and see the data coming to that. And the Dexcom app is what allows you to go with remote monitoring and share and the things you normally do. You can have targets, which you can set, and you can adjust them by different times of the day. So you can have someone with a target of 110 overnight and 120 during the day. Say they went to school, say COVID ended and kids actually went to school. You can say, I have a young kid, a 5-year-old, I'm worried about him getting low with a teacher around that doesn't know him that well, so I'm going to raise the target to 120 or 130 during the day. I mean, when he's with me, I'll put him at 110. Or you can say, I'm worried about lows at night, I'll have 120 overnight and 110 during the day. You can change it how you want. It has a very good hypoprotect feature, which does 3 things. It raises the target to 150. It cuts the projected basal rate down by 50%. And if it sees a rise in glucose, it dampens the insulin response to that. So if you treat a low when you're exercising, you don't over-deliver insulin. So it's a pretty good hypoprotect feature. And every time you change a pod, it adapts to what your insulin needs are. So as you're wearing it, it's continually adapting to what your needs are over time. Again, we tested this with it on a tablet, and Lisa Norlander did a lot of these studies with us and spent nights in the hospital and not in the hospital initially, and then in Airbnbs. And we got 13,000 person hours in testing from age 2 on up. So if the algorithm had a lot of testing before it went into this pivotal study. This is testing the preschoolers, 2 to 6 years old. One of the parents brought in this bouncy house, And you can see them periodically. You can see the boys being aggressive with each other, and you see girls just looking cute. And you can see the pods, and here's a pod going on. We never lost a pod or CGM with all this. This little guy now is going to have his revenge. Knocked him down. Okay. So at any rate, I just want to let you know we're doing the pivotal study for preschoolers in about 3 weeks. And so if anyone has or knows of any 2 to 6 year olds who would like to be in the study, I think we're getting close to filled up, but send me an email. And it's a 3-month outpatient study, and then it will be followed by an extension phase. This is the, for the older kids that we've done, this was the goal. We did 6 to 70 year olds. And we were required, when we got started, I thought this was just interesting data. I have a lot of interesting data here, which I throw in, and I'm almost done. I haven't even started yet. But this is just looking at the data from Gluco of CGMs uploaded as part of the Omnipod system, and looking at their time in range. And what you look at this big dip here when you get into your holidays. Could you imagine people would begin to eat more and their time in range would go down over the holidays? It was, you know, just surprising that would happen. So that's when we did the study. So we brought them into an Airbnb and did a study on these kids. And I'm out of time, so I'm going to go quickly. But they, in the 14 to 70 year olds, their time in range was about 66% on standard therapy, and on the hybrid closed loop, it was about 74% time in range. If you look at the percent time hypo, it went from 2.6% to 0.9% and 0.5%. These are very low hypo percentages. The hypo protect really works well. And this is the 6 to 14 year olds. Time in range, standard therapy was 51%, and went up to 70% when they were at home. So really good. And again, the percent time hypo was very low initially and stayed low. Their projected A1C glucose management index went from 7.7 to 7.1. So, and this is the typical visual going from midnight to midnight of this is the on the closed loop system in the blue, and then the orangey red is not a closed loop. And you can, and the system worked 97% of the time. So at this point in time, it's 5:56. So I'm going to open it up for questions, and then I'll move on to the rest of the talk if people want to stay. And I'm sorry I'm so chatty.
That's all right. There's a few questions that have come through the chat. What system do you like best?
I think they all have advantages, and everyone has to go for their personal needs, and I would never tell anyone this is the one for you. What I really like is for people to volunteer for studies, and then they can try them all before they make a decision. Come do a study with us.
That's what I did.
So I think the new 780G, as I say, is probably one of the more aggressive, and does in for people that are a little late in bolusing sometimes, or miss a meal bolus occasionally. It's going to be a real advantage for them. Because at a 100 set point and a short active insulin time, you're getting close to 80% time in range. The Tandem IQ uses a Dexcom sensor. You know, it's factory calibrated, big benefit. It has a lot of features to it. It seems to, you know, you get benefit no matter what your level of control is, whether you're tightly controlled or not. And it's and I like the way it brings things down overnight to a tight range in the morning. The Horizon system, I mean, it's an entirely different pump. It's a patch pump. It's using the Dexcom sensor again, but you're changing it every 3 days, but you're in auto mode as long as you're wearing it. And it will adapt over time. Does very good at hypoprotection. So they're all unique, and some people are very strong pod users and really like wearing a pod. Some people are really, have been wearing Medtronic for a long time and are used to it. Other people are very strong Tandem and Dexcom users. So I think I'm going to give my last slide here. So you missed a lot. Okay, I'll go back and give it all if you want, but I should mention other trials that we're doing. I was trying to, this came out this week in Diabetes Care, and it was looking at time in range, comparing closed loop here. So you want to be more here, and they're much higher here. And unfortunately, the slide I didn't get the bottom axis somehow, but you're much higher here with closed loop time in range compared to MDI plus CGM, MDI plus flash glucose monitoring, MDI to self glucose monitoring way down here, and to a nocturnal closed loop. It does pretty good, but and this is a sensor augmented pump here. And it's an improvement, but you get your best improvement if you're in closed loop. And if you look at reducing time less than 70, again, your biggest improvement is when you go to closed loop or with a low glucose suspend. Any of the ones that have nocturnal closed loop or low glucose suspend decrease your time less than 70. So I think as long as you're on a closed loop system, you're probably going to be doing to a large extent better, at least in reducing lows and cutting down the high time. And I just saw that and just wanted to point it out. We're working on having infusion sets that'll last 7 days. And Medtronic, we're doing a study with them, and it's a 7-day sensor, a 7-day infusion set that seems to be working really well. We want to get sensors to percent error less than 10%. And I think the next thing is really no carb counting and going to full closed loop, no pre-meal bolus. It may not be perfect, but I think it'll get you 70 to 75% time in range. And that's going to prevent the long-term complications. And if you don't have to count carbs or worry about eating, hey.
Diabetes gets a lot easier there.
A lot easier, and this is our team here. So I'm going to stop. If anyone wants me to go back and talk about Beta Bionics and the iLet and some of the other things, and the co-administration of insulin with pramlintide can really flatten postprandial glucose values, and some other stuff, the Clue Watch, I'll go back and do that. Otherwise, if everyone has something to do like eat dinner, which
we actually have a few.
It could be a margarita. I don't know. At my beach, they're offering margaritas now.
We actually have a few questions here. So what do you think of the looping system and about using FEOSP and faster acting insulins?
So I will tell you, I have a little slide on them, but I think what I like about all the, where do they go here? The loop system was built by people with diabetes. For people with diabetes, they have the Night Scout for monitoring, which is really nice. When the pod came out and they could hook it up to a commercial, currently available commercial pump, it really picked up loop usage. And it has nice features on an Apple Watch. You can do everything from the watch and control the type of food you're eating, whether it's a lollipop or a taco, for a standard meal and pizza for one of those long-acting meals. And and it's easy to dial in and do. There is some initial adjustment, but all the tuning is sort of things that we're used to in terms of carb ratios, insulin sensitivities, active insulin time. I mean, they aren't that much different than what we normally do. Tidepool is developing its own Loop app. That would be an app you would just put on your phone, and I think that's really great. And it's it'll make it sort of seamless. You don't have to buy an app to become a programmer for Apple to get it. It would just be one of those apps that are available to you. So I think a lot of people have found great benefit with them. You are using Riley links and different things. I think there's a little more stuff you're carrying around. There's probably sometimes more communication, battery issues, and the usual things when you piece together different parts from different companies. And when you get an integrated system that's been commercially developed, that communication is generally a lot better and more solid. So that's the advantage of a commercial system that's gone through the FDA. But the Tidepool will go through the FDA.
And then what about using the faster acting insulins on the closed loop systems? Would it be too complicated to reset basals and insulin to carb ratios and things like that?
So it's been tried on the Medtronic system, and it's been tried on the Beta Bionic system, and without making any change in the tuning parameters, it did not do any better. It was also tested on with the DreamWorks system out of Israel and Slovenia, but it didn't make any difference.
Okay.
I think, and people are now working on tuning the algorithm, changing your time to peak and tuning that in the algorithm, and you can easily do that. And Beta Bionics thinks they're seeing an improvement once they did that. And we're seeing if Medtronic is going to try that now too. So it's something to be worked on. And I think it's flat out of the box, not tuning for it doesn't seem to make any difference. Tuning for it may make a difference.
Okay. And then are there any updates with faster acting insulins?
Funny you should ask. So, wait. Well, there's the Lilly insulin. I actually didn't bring a slide of it. I'm sorry. So there's the Lilly insulin, and it may be actually a little faster than Fias, and it works well. I think with all these things, they start out as injections and then they're moved into pumps, and we'll have to see. You know, it has a vasodilatation to it, and whether that becomes irritating over time or not. Are there any more little local pump bumps and things like that with it? We'll have to see, but it has good, you know, it significantly improves onset of action.
Okay.
So.
And then is there any news on whether Medicare will cover these systems? I think they currently cover Control IQ, but what about Medtronic?
You know, I don't keep up on Medicare just because I'm a pediatrician, I guess. But I thought Medtronic actually had locks on some of the healthcare providers to some extent for adults. I mean, there was, I was going to show it here. Let me see if I have. This is for Apple now. Here. So they had an exclusive with United Healthcare. So if you had United Healthcare, you got a Medtronic pump, and they had 5,000 people on it. And they had, what came out of the data, they don't have exclusivity there anymore. But when they looked at the data, there was 27% lower rate of preventable hospital admissions in the first year of the agreement. And it was 33% lower in the second, and 38% lower in the third. So being on the system significantly decreased hospitalization costs. And I think that's important information.
Dr. Buckingham?
Yeah.
One question. And this kind of goes back to the faster acting insulin. To me, it feels like the gap between like a true like solution that really beats these versus what we have now is faster acting insulin, in the sense that when your blood sugar gets high, if you had something that, it just takes a long time for Humalog to take action, and a lot of the lows are because the insulin is lasting too long. So something that got in and out of your system faster, I feel like would be like really the change versus improving. I mean, improving AI algorithms might help a little, but I was just thinking, I'm using the same insulin I used when I was diagnosed in 1998. So is there any, I still use Humalog. Is there any reason that that's one technology that just can't seem to get that much better? And do you agree that that's really the missing link here?
I think it would be great. I mean, there are, at one point in time, Medtronic had an implanted pump, and so the insulin was delivered intraperitoneally. And what people found was it was a really fast on and off. When it goes into your peritoneal system, it's delivered directly to the liver where it's supposed to go, instead of under your skin and then circulate around, and it had much less of a depot effect. So when people got low, they could shut off their insulin and immediately could feel themselves coming up pretty quickly. And it was used actually for people with a lot of hypoglycemic problems and hypoglycemic unawareness. They would get these implanted pumps. And so if you delivered it at a different site, if you had intraperitoneal, if you had insulins that were specific for the liver, is one thing people have talked about. Getting the sub-Q absorption quicker. They've been trying with these vasodilators. PS has nicotinamide, niacinamide in it, and the Lilly product has a vasodilator. So they're trying to get it in quicker. There was hyaluronidase, which sort of digested the hyaluron in the space, so it allowed quicker permeability, and it had a faster onset of action. But it's not perfect. Let me show you one thing real quick. I don't know when I did it. I don't know where it is here. But we had this app on your watch, and it would, by your wrist motion, it would say, oh, you're eating. When you bring your hand to your mouth a couple times, it would say you're eating food. And it was to remind kids that say, are you eating? Have you bolus? And you go, yes, I bolus. And when we did that, it dropped their A1C. It was 8.3, and they started down to 7.8 by 0.5%. But if you look at what happens, this is food recognizing 23 bites. If you look at when a sensor can recognize when you're eating, you can't necessarily call this eating here. But when you jump up here, you can probably say you're eating. But that's 18 minutes later. So the physical action of eating precedes what you can see in a sensor. So that's another lag time. You're eating, you're putting food in your stomach. If you don't have diabetes, when you see food, smell food, you release insulin. You are getting a little insulin release to prepare you for that food. Okay, it's the frontal lobe. It's your brain responding to it's the dog salivating when he hears the bell and knows food's going to come. And so you can, by this hand gesture, you can pick up 18 minutes before you actually see it in your sensor. And then, of course, once you see it in the sensor, you have another 15, 20 minutes before the insulin reaches an effective level. So you're now, if you're in full closed loop, that's why you want to give the insulin 10 minutes before you start eating, and then this peak corresponds with this peak. And yeah, a faster insulin would help, but even a faster insulin is going to begin here, and it's still probably going to take 10, 12 minutes to really become effective, and you're already moving up like this. So it would be much better, and it would be much more ideal, but it may take a combination of things. that make this happen. This particular person, they detected meal on the watch here at 9:16. Again, they didn't bolus. This guy never bolused. His blood sugar is going up, and it's detected on the sensor out here. Again, about an 18-minute play. Now, I'll say this watch app was bought by Medtronic, and they're working toward a full closed loop, so it may be part of that since they bought the system. They bought the person that invented it. Let me just get down to oh no, gotta go up. I don't know where I am in this slideshow. I'm sorry, but I thought this is very interesting, just in terms of other ways to get around it. That this is taking pramlintide, which delays stomach emptying. So it gives you a much flatter curve. So this is in a closed loop. And here's when you just have the standard meal bolus. And this is when the pramlintide is given at the same time as insulin. So they're in a molar concentration. And when you give the pramlintide, you have a flat postprandial curve. So, and this is with a standard insulin. And you look out here, it's darn near flat. So I think that would be interesting. This is where he had them wearing 2 pumps. And they had a pump delivering insulin, a pump delivering pramlintide. And the pramlintide had a program based on every time they gave a bolus with the pump, they gave a bolus on the pramlintide pump. But now, Adosia has co-formulated pramlintide with insulin. Pramlintide has a pH of 4, and glargine insulin has a pH of 4. So they took the insulin and glargine, mixed it with the pramlintide, and now you can have them co-formulated, so you can put them both in the pump. And whenever you're delivering a meal bolus, you're delivering pramlintide, and you get that flat effect. So there are a number of different ways around this. So I know I talked everyone out of their dinner, so I should stop. But these are great questions. These are really important, great questions.
Okay, does anyone else have any questions? Feel free to unmute yourself and ask away. Okay.
Ragnar's roasting marshmallows now.
Okay.
Actually, one clarification. Do all the closed loop systems you talked about have, in your opinion, equal night control? Because it seems like we sleep a third of the day. That's a real low-hanging fruit to get good control over, because you don't have as many variables. You're not eating, you're not exercising, right? Yeah. So do all 3 systems, do you feel like give the same amount of night control?
Yeah, I think they do fairly comparable at night. They're pretty close. They're pretty similar. And often you're getting well above 80%, sometimes 90% time in range overnight. Most of them give a very low incidence of lows overnight. And I think they're really good at that. That's where closed loop really shines. When you get rid of meal and exercise disturbances and you're in a stable state like that, and you get a glucose, if it's a reliable glucose and you're looking at it every 5 minutes, they do great. Loop does it, all of them. So what people love when they go on closed loop is the nighttime to a large extent. Waking up in the morning with a good glucose without having lows at night or a lot of highs overnight. So yeah, and that's why you see that jump on day 1 in the Tandem Control IQ. They're hitting that 70% mark almost on day 1, and most of it's due to that nighttime. A big bulk of that improvement is the nighttime.
Great, thanks.
Okay. And then Dr. Buckingham, there's been a few questions on how to get involved with research studies at Stanford. So if you could maybe just touch on that, what's the best way to get in contact?
we have a study login where you can register and get on. But if you send me an email, because I don't have it showing up here, am I stupid? But I'm Buckingham@stanford.edu, and it's just my name, Buckingham@stanford.edu, and I will send you the link to the database. And if you give any additional information, it's always helpful. Your age, what system you're on, things like that. Just sort of tell us what study you might be eligible for.
Okay. And then for the people that were interested, I added Dr. Buckingham's email into the chat, so you can copy and paste that and save it on your computer. So when you have time, you can reach out.
Great. Well, I should let people go. If anyone had any burning questions about any other closed loop system, happy to talk about them, and just stay on and we can go over them.
Thank you so much.
Okay, thank you.
Thank you very much.
Bye.
Okay, have a good social hour.